Hello students, welcome back to the Nazir physics classes. I have already completed rotational dynamics, but now I want to do some problem sets on rotational dynamics. The first problem set is on how to locate the center of mass of multi-body system. So I have taken a very simple example. Example number 1. These are three masses just on the x-axis, and all the three masses have the same mass, 1 kg, 1 kg and 1 kg, and their location is coordinates are given 0 0 2 0 6 0 because it is on the x-axis. Therefore x coordinate is 0 2 6 and y coordinate is 0, right? So how to locate the center of mass? Obviously the center of mass of these three masses will lie on the x-axis. Because all the three particles are on the x-axis, there is no y coordinate. Of y coordinate is 0 for all the three masses, and we will have only the x coordinate of the center of mass. So what is the formula? The formula that I already discussed with you. Formula is axiom center of mass, x coordinate of the center of mass is m1 x1 plus m2 x2 plus m3 x3, because there are only three masses. Therefore we will go only up to summation up to only three masses, and then divided by sum of the masses, right? So that is m1 plus m2 plus m3. Is it right? This is the formula that we have already obtained. We did a lot of mathematics with this earlier when I started the lectures. Okay, now axiom equal to, what is m1? Take this as 1, 2 and 3. This is m1, this is m2, this is m3. So what is m1? That is 1 kg. What is the x coordinate? That is 0. m2, again 1 kg. What is the x coordinate? That is 2. What is m3? That is 1 again. What is the x coordinate? That is 6. Divided by 1 plus 1 plus 1. All the three masses have 1 kg each. So how to write it down? That is 0 plus 2 plus 6 by 3. That is 8 by 3. That is 2.67, something like this. Okay, centimeters, if their coordinates are in centimeters. That is all. So here we are locating the center of mass of discrete bodies, and it's very simple axiom. Agar y coordinate bhi hota, to we write ycm is equal to m1 y1 plus m2 y2 plus m3 y3 divided by sum of the mass. And the same formula is in areas a1 x1 a2 if they are discs like. Same formula we can extend in terms of volumes. v1 x1 plus v2 x2 plus v3 x3 अगर इन बॉडीज का वॉल्यूम दिया हो, अगर इन बॉडीज का एरिया दिया हो, तो एरिया में हम इक्वेशन लिख सकते हैं. लेकिन उस सूरत में ये होना चाहिए कि all the bodies must be of the same material. I mean their density must be the same. If there are different densities, then we do have to write down the masses of individual masses. And this is problem number first. Now let us go to the problem number second. Second problem. We will go to the second problem. Okay, this is our problem number second. Our second problem is, these are three masses at the three corners of this triangle, right angle triangle, with sides 4 centimeters, is 5 centimeters, is 3 centimeters. Obviously 3 and 4 will make this 5. And masses are 0.5 kg here, 1 kg here, and 1.5 kg here at this position. The coordinates are given 0 0 because it is 4 centimeters, therefore it is 4 0. It is 3 centimeters and is on the y-axis, therefore x coordinate is 0 and y coordinate is 3, right? And we have to find the center of mass of the system of these three masses. So what to do? Okay, let me make it simpler. Here, what is m1 here? Okay, let me take m1 here, 0.5. m2, that is okay, second mass here, that is 1 kg. Third mass m3, that is 1.5 kg. Okay. right? So what's the x1 coordinate? That is 0 here. What is x2 coordinate? Here, mass of the second particle coordinate, that is 4. What's the x3 coordinate? That's coordinate x3 coordinate, x coordinate of the third object, that is 0. What is y1 coordinate? Coordinate of the y coordinate of the first particle, that is 0. What is y2 coordinate? What is the coordinate of the second particle? That is 0 again. What is y3 coordinate? That is 3. Let me put it like this so that things become very easier. So what I have to find is that I have to find the center of mass position of the system of these three particles. So finding the center of mass position means finding the coordinates of the center of mass. And the formula for the coordinates are so simple. It's given. We know the formula: xcm, ycm, and zcm. xcm in terms of, ycm in terms of known quantities, zcm if at all in terms of known quantities. But we don't have zcm because all the objects lie in what? In the xy plane. If the objects would have been there in the space having the z coordinate also, then we would need z coordinate also of all the particles, of some particles. Okay, now xcm. What's the formula? m1x1 plus m2x2 plus m3x3 divided by m1 plus m2 plus m3. Write down now the values. That should be very simple. m1 0.5 into x1 0 plus m2, that is 1, x2, that is 4, plus m3, that is 1.5, that is x3, that is 0, by sum of the masses m1 plus m2 plus m3, 0.5 plus 1 plus 1.5. So that will become, it will be 0, it will be 0, it will be 4 divided by, it is 1.5, 0.523. That is, okay, that is 1.33 centimeters. X coordinate. What about the y coordinate? YCM, that is m1y1 plus m2y2 plus m3y3 divided by sum of the masses, again that is 3 kg. This plus this plus this is equal to m1, that is 0.5 into what? y1, that is 0, plus m2, that is 1, into what is y2, that is again 0, plus m3, that is 1.5. What is its y coordinate? That is m3 is 1.5, and what is its y coordinate? That is 3 divided by 3. That is YCM equal to, this is 0, this is 0, this thing cancels, 1.5 centimeters. Answer. So it is y coordinate and this is x coordinate of the center of mass. That's all. That's all. This is the third problem. What is the third problem on center of mass location is, it's a disk of radius r. It's a disk of radius r. It has a hole here at the extreme end whose radius is r by 4. We have to locate the center of mass of this disk with a hole. Obviously, it will be shifted to the left side of the y-axis because now it will be a greater mass side on this side. We have to locate the center of mass of this disk with a hole. So how to do it? What is the technique to do it? So what we do is like this. Have a look. It's a disk. It is a disk with a hole here with r by 4, and this center of this hole has a coordinate with respect to this center. What is that? That is r minus r by 4. That is r minus r by 4. That is 3r by 4. We have to find the center of mass of this remaining part. Suppose that is here. How much away? Okay, xcm. This is the center of mass of this disk with a hole. So how to locate the center of mass of this disk with this hole? What I will do is, if I this is a disk, little disk here with the radius r by 4. If I put this disk here, get this disk and put this disk here, solid disk, the center of mass will be shifted to the center, because by that argument it will become a complete disk. जब ये कंप्लीट डिस्क बनेगा तो सेंटर ऑफ मास सेंटर में चला जाएगा. इसका मतलब सेंटर ऑफ मास ऑफ दिस डिस्क विद ए होल प्लस दिस लिटिल डिस्क विल बी हियर. तो मैं इस डिस्क को उठाकर, इस सॉलिड डिस्क को, लिटिल सॉलिड डिस्क को उठाकर यहां रखूंगा, और जब मैं यहां रखूंगा तो सेंटर ऑफ मास यहां चला जाएगा. सो नाउ दीज आर टू ऑब्जेक्ट्स. वन ऑब्जेक्ट इज this object. One object is this disk with a hole. It is center of mass is axiom, and there is another. Let me put it just the corresponding way here. This is the disk with a hole, and this is complete disk here again. Here one more point here. तो इन दोनों का जो सेंटर ऑफ मास है वो ये है, दैट इज हियर. मैंने ये उठाकर यहां रखा तो इसका सेंटर ऑफ मास ये है, और बाकी जो ये डिस्क विद ए होल है वो उसका सेंटर ऑफ मास यहां है, और उसको मैंने ये समझा. अब इन दोनों का सेंटर ऑफ मास, इस डिस्क विद ए होल विद दिस सॉलिड लिटिल डिस्क, देयर सेंटर ऑफ मास इज दिस. तो इसका मतलब ये एक्सियम है, और ये कितना है, how much away the center of mass of this solid disk which I put here is away from the origin, that is 3r by 4. That is 3r by 4. That simply means, so what was the formula that we used? Is the area A1, it is area A2, and their center of mass, let me suppose it is this, suppose it is x1, it is x2. What is the condition that the center of mass is here? There is A1 x1 is equal to A2 x2. That is the condition, that it may be M1 x1, M2 x2. It may be V1 x1, volume times x1, volume times x2. The same condition applies. So what should we write here? Axiom into area of this disk with a hole. What is the area of a disk with a hole? Suppose A1 is equal to 3r by 4 into area of this disk square A2. What is this A1? Axiom. What is this A1? Area of this disk with a hole. That is pi r square minus area of this. That is, what is that? That is pi 3r by 4 square. Area is r by 4. R square by 16 is equal to 3r by 4. What is A2? Area of this disk, which I placed here, that is pi r square by 16. Yes. तो solve for this axiom. तो कितना होगा axiom? That is 3r by 4 into pi r square by 16 whole divided by 15 pi r square by 16. तो ये खत्म हो गया, 16 भी खत्म हुआ, 3 5 that is r by 20 is the answer. So it will shift, the center of mass of this disk with a hole will shift to the left side of the origin by r by 20. This is a technique, please learn this technique by heart. अगर ये डिस्क यहाँ खाली है थोड़ा सा स्पेस, तो उस जैसा डिस्क आकर के यहाँ रख दो, और दोनों का, इस पार्ट का और इस पार्ट का सेंटर ऑफ मास यहाँ चला जाएगा. फिर सेंटर ऑफ मास ऑफ दिस डिस्क into this is equal to this disk into its distance from the origin. So that technique you use, you will get the answer. You will get the answer. It is one more problem here. One more problem. Fourth one. Have a look here. It's a boat. Let me suppose it is on water where friction is very small, or it may be a smooth surface where there is no friction. The boat is there on the water, or it may be on the frictionless surface. Both will work, because on water surface we say friction is as less as possible, negligible. A person is in the boat, he is here, and the length of the boat is L. तो ये जो person है, it starts running towards this end and reaches here, and the boat will go in the, it will, ये पीछे खिसक जाएगा boat, it will recede in the backward direction. हमें देखना है कि if this person reaches over here, ये boat जो है कितना पीछे चला जाएगा. You are on the boat, you move on the boat, you run in the forward direction, the boat is on the water, the boat will go in the backward direction, right? तो अगर आप, if you travel full length of the boat, अगर आपने पूरा length boat आपने travel किया, and you have gone from one end of the boat to the another end, तो ये जो boat पीछे कितना खिसकेगा, पीछे कितना जाएगा. तो पहली बात है, पीछे जाएगा क्यों? पीछे इसलिए जाएगा, जब आप आगे रन कर रहे हो, there is no external force on the system of you and the boat. External force तो है नहीं. There is no external horizontal force. जब external horizontal force नहीं है, इसका मतलब horizontal direction में center of mass should remain at rest. Center of mass should not move. But you are taking your center of mass the forward direction. Therefore, the boat should take its center of mass, अपना boat जो अपना center of mass boat का, that should go in the backward direction, so that the total center of mass of the system remains where it is. इसने अपना सेंटर ऑफ मास आगे लिया, बोर्ड को अपना सेंटर ऑफ मास पीछे लेना चाहिए, ताकि जितना उसने सेंटर ऑफ मास आगे लिया उतना बोर्ड पीछे लेना चाहिए, ताकि सेंटर ऑफ मास जहां है वही रहेगा. वजह, बिकॉज देयर इज नो हॉरिजॉन्टल फोर्स. व्हेन देयर इज नो हॉरिजॉन्टल फोर्स, व्हेन देयर इज नो हॉरिजॉन्टल फोर्स, then center of mass position should not move in horizontal direction. ये है कॉन्सेप्ट. तो अब आप मुझे बताइए, the person, how much the person take a center of mass the forward direction. जब ये person has gone from here to here, how much center of mass has taken the forward direction? You feel it has taken this, if it is own center of mass, अपना center of mass ने आगे L लिया. ठीक है, इसके फ्रेम ऑफ रेफरेंस में इससे ये L चला, लेकिन बाहर के फ्रेम ऑफ रेफरेंस में ये L नहीं चला, ये यहां से यहां गया, मतलब यहां से यहां गया. It has taken its center of mass L minus x in the forward direction. In the frame, in its own frame of reference, it has gone L. But for a person on the shore, or for a person rest on the shore, he will go a distance L minus x. So how much center of mass he will take in the forward direction? That is m L minus x. This is the center of mass being taken in the forward direction, plus how much the center of mass taken in the backward direction? That is mx. या ऐसे भी लिख सकते हैं, m into L minus x is equal to m heavy mass taken the center of mass the back direction. How much? बोट पीछे कितना हटा? x. Go boat has taken its center of mass by distance x. मगर बोट is, इसका मास इंटू एक्स कंट्रीब्यूशन होगा सेंटर ऑफ मास का. सेंटर ऑफ मास का कंट्रीब्यूशन नहीं होता है कि इतना ही कि ये एक्स गया तो सेंटर ऑफ मास हैज शिफ्टेड बाय एक्स. नो, सेंटर ऑफ मास हैज शिफ्टेड एम इंटू एक्स. इसका मास भी कंट्रीब्यूट करेगा, ये कितना गया, डिस्प्लेसमेंट कितना गया वो भी कंट्रीब्यूट करेगा, उनका प्रोडक्ट कंट्रीब्यूट करेगा. A small mass has to go a long distance and a heavy mass has to go a little distance to contribute by the same amount of center of mass. तो ये it is m into this x. तो इसमें हमें x मिलेगा, ml minus mx is equal to mx. So it is ml is equal to, यहाँ x कॉमन निकलेगा, m plus x. तो what is x? That is ml by m plus m. That is the answer. So the boat will go ml by m plus x in the backward direction, because man goes in the forward direction. Man goes in the forward direction on the boat will go in the backward direction by this much of amount. Obviously, the boat will go by a small amount, because boat may be heavier. and the man goes by a longer distance because man is lighter. जो मैन का कंट्रीब्यूशन है इन द फॉरवर्ड डायरेक्शन उतना ही कंट्रीब्यूशन बोट का होना इन द बैकवर्ड डायरेक्शन सो दैट द सेंटर ऑफ मास रिमेन्स वायर इट इज. ओके, दिस इज फोर्थ प्रॉब्लम. लेट मी गो टू द फिफ्थ वन. This is the fifth problem. The problem is like this. A block of mass m slides down the incline. The mass of this block is m and the incline, that solid incline, this has a mass 10m, right? It moves downwards, but while it moves downwards, it pushes the block in the backward direction because there is no friction on the base. कोई friction नहीं है base पर, वो ये पीछे खिसकेगा, ये नीचे आकर के ये पीछे हटता जाएगा. हमें देखना है कि when the block comes down, how much this incline shaped wedge, how much it has gone in the back direction. हमें ये x निकालना है. ये जो ब्लॉक यहां पहुंचता है, यहां कहां पहुंचेगा तो यहां पर, क्योंकि ये पीछे हट जाएगा. जब ये यहां पहुंचा तो हमें देखना है कि ये जो ब्लॉक है कितना पीछे हटेगा. ब्लॉक पीछे हट गया. पहले ब्लॉक का एंड ये था, अब ब्लॉक का एंड ये है, तो ब्लॉक x पीछे चला गया. तो ये ब्लॉक दिस इंक्लाइन पीछे x चला गया. लेकिन ब्लॉक यहां आया ना, तो ब्लॉक कितना आगे आया? लगता है ब्लॉक यहां से यहां आगे L आया. लगता है जो ब्लॉक यहां से यहां हुआ तो आगे ये मतलब फॉरवर्ड डायरेक्शन में, हॉरिजॉन्टल डायरेक्शन में इसने L ट्रैवल किया. लेकिन नहीं, इसने L माइनस x ट्रैवल किया. लेकिन बिकॉज व्हेन इट फॉल्स ऑफ इट पुश दिस इंक्लाइन बैकवर्ड्स एंड इट आल्सो मूव्स बैकवर्ड्स अलोंग द इंक्लाइन. तो लास्ट में जब यहां आ जाता है, ये ब्लॉक पीछे x हटा, इसलिए ये जो ब्लॉक है ये आगे कितना आया? ये सिर्फ इतना आगे आया. पहले यहां था, फिर आखिर में यहां हुआ, तो आगे सिर्फ इतना आया. तो मींस इट हैज कम फॉरवर्ड L माइनस x. तो अगर फोर्स है तो वो ग्रेविटेशन फोर्स है, दैट इज डाउनवर्ड्स, राइट. लेकिन हॉरिजॉन्टल फोर्स क्या है? इस डायरेक्शन में फोर्स क्या है? F, 0. There is no force in the horizontal direction. So when there is no force in the horizontal direction, therefore the center of mass position of the whole system should not move in the horizontal direction. This सारे सिस्टम का जो सेंटर ऑफ मास इन द हॉरिजॉन्टल डायरेक्शन है, उसका जो हॉरिजॉन्टल कोऑर्डिनेट है, उसका जो x कोऑर्डिनेट है, दैट शुड रिमेन अनचेंज्ड. लेकिन लिटिल मास मूव्स डाउन. सो लिटिल मास तो अपना सेंटर ऑफ मास फॉरवर्ड ले रहा है. इसका मतलब ब्लॉक अपना सेंटर ऑफ मास पीछे ले जाना चाहिए, सो दैट द सेंटर ऑफ मास रिमेन्स एट रेस्ट. टेल मी, सो x coordinate of the center of mass of the system, x coordinate of center of mass of the system must remain unchanged. Why? Because F horizontal is 0. Horizontal force is 0. So ये जो M है, how much it has taken center of mass in the backward direction. इसने सेंटर ऑफ मास कितना इसने सेंटर ऑफ मास कितना अपना आगे लिया? ये देखो, हॉरिजॉन्टल डायरेक्शन में फॉल तो हुआ ऐसे, लेकिन उसके दो कंपोनेंट, हॉरिजॉन्टल एंड वर्टिकल. वर्टिकल में कोई प्रॉब्लम नहीं है, वर्टिकल में तो सेंटर ऑफ मास मूव कर सकता है डाउनवर्ड्स बिकॉज देयर इज अ वर्टिकल फोर्स. बट हॉरिजॉन्टल में इसने सेंटर ऑफ मास इतना आगे लिया with its mass contribution, so it is m into how much distance forward, that's L minus x. That should be equal to 10m. कितना पीछे हटा है? 10 ब्लॉक, ये जो इंक्लाइन ब्लॉक है कितना पीछे हटा? x. So it is 10m into x. हमें x निकालना है. ये जो ट्रायंगुलर ब्लॉक है ये कितना पीछे हटा? ये वेज है, ये कितना पीछे हटा? तो हमें x निकालना है. So that is m gets cancelled. L minus x is equal to 10x, right? So 11x is equal to L. X is equal to L by 11. So if L was given in the problem as 2.2 meters, so what is x? x is equal to 2.2 by 11. It is 0.2 meters. That's all. So it is very important that if there is no force in the horizontal direction, the center of mass in the horizontal, the x coordinate should remain unchanged of the center of mass. So it is of the whole system. लेकिन system में कोई particle अगर move कर रहा है, the other particles also move so that the center of mass remains at rest if there is no external force. Thank you. But don't forget to download my app, Tantray Sir Physics class, and also watch my lectures on the YouTube. I'll be taking the course in the forward direction, and I will deliver possibly a few more lectures on the problem solving sessions online. Thank you.